Hello all. Have you ever trained a machine learning model and it performed great on your data but failed miserably on new data? That's because you might not be testing it properly. Today, we will learn a powerful technique called cross validation or CV that help you reliably evaluate your model before putting it in the real world. Cross validation. Cross validation is a method that helps us evaluate the model performance. Instead of relying on a single test set data, we split the data into multiple parts. This way, every part gets tested, giving us a better understanding of how the model will perform on new unseen data. If we test the model on only one holdout set, the performance estimate may not be accurate. The model could perform well on that specific set but fail on the other data. Cross-validation splits the data set multiple times to reduce the risk. By using cross-validation, we reduce the risk of overfitting, get more reliable performance metrics, and gain confidence that the model will generalize well on the new data. So how we will use this cross validation? So let us take an analogy, the chef test. Imagine you are a chef testing a new cake recipe. You have 10 friends and you want to see how everyone likes a cake. But instead of giving it all 10 at once, you divide your friends into cake groups. For each round, you let k minus 1 groups taste the cake while keeping one group aside to judge it. You rotate so every group gets a turn as a judge. Finally, you average all the scores to decide if the cake recipe is perfect. So now we will see the machine learning translation. Split the data set what you have into k folds. Example k equal to 5 or 10. Train the model on k minus 1 folds. Test the model on the remaining fold. Repeat until each fold has been the test set once. So now calculate the performance metrics across all the folds. So there are different types of CV. One is K-fold CV, which is commonly used, stratified K-fold CV, which preserves class balance, leave one out CV, and repeated CV, which runs multiple times with different splits. So why we use this cross validation? It provides more reliable estimate of model performance than a single train test split. It helps to detect overfitting early, works well with small dataset, and it can be combined with hyperparameter tuning for better models. Instead of trusting one friend's taste, you gather feedback from everyone in different rounds. This ensures your cake is actually good. So here in this code, we split the iris data into 5 folds and it is trained a random forest on 4 folds, tested 1 fold and repeated this 5 times. The average accuracy gives a reliable estimate of model performance. So this is a small ad quiz. What type of CV would you use for a imbalanced data set? And that's it for today. Now you know how to use cross-validation to make sure your machine learning models are robust and reliable. Thank you.